Yeah, we'll get back to the area of bioenergetics and growth in the heifer. It's one of those interesting things, and I have a couple other examples for you, that we tend to think that we've always known everything about cows, and we haven't. The area of understanding the biology of the dairy cow is relatively new, and really the person who started working the most on the growth of the dairy heifer, at least in modern times, was a gentleman by the name of Samuel Brody, and published his first large work on that in 1945. So it's not that old. It's getting old, but not that old. It's not 1600 or something really old. But about the time of the end of World War II, this was a normal-sized dairy cow, a Holstein. These aren't giant people. These are normal-sized people. That's just a small cow. And she was about this high, and she produced maybe at the most 10 kilos of milk for maybe 45 to 60 days. So that was a lactation of that animal. And since 1945, we have selected for genetics year after year after year, and we've created the animals that we now have. So tremendous amount of genetic selection has taken place. But anyway, Dr. Brody did a lot of work just looking at the various different breeds and studied a lot of growth patterns and longevity and very interesting stuff. You can still find his book in sometimes in a city like this, you might find his book in some used bookshops. There was a lot of them around. And you can go on to Amazon and buy one, I think, most time. We've done a lot more work. That's one of the things that my students and I did a lot with, was looking at the growth curves of these animals and trying to understand what is modern growth compared to where we were in the 1940s. But basically, this is the growth pattern of a mammal, or of a heifer. It's the same as a human, it's the same as a pig, virtually. But we have two distinct phases of growth in the dairy heifer. One is from birth to puberty, and there is a distinct point of inflection at puberty where growth rate changes. And so whenever we model growth in a heifer, we always have to look at day of puberty, and we've done research where we're collecting blood, so I know day of puberty, and it is phenomenal that growth rate changes on that day, and it flattens out. And so I don't have a time on this because puberty is normally around 50% of mature body size, but it is somewhat related to body fat, not necessarily weight. There's a fat ratio that really affects that more. From a standpoint of the producer, one of the things tomorrow I'll talk about a little bit is the economics of heifers. But the economics of heifers is we want to get puberty in terms of age. We want that younger, but we have limitations there. And we want calving somewhere out here closer to larger size, but again, there are limitations there. Maturity in a Holstein is about 54 months of age. So you're looking at a 5-year-old animal, before they're completely mature. But growth does level off a lot here. So the point when we look at management and nutrition of the heifer is in this time period here, the growth is the most rapid that this heifer will have any time in her life. And it is primarily muscle and skeletal tissue. So from nutrition, muscle is composed of protein, which is composed of amino acids. So for nutrition, I want to focus on protein and calcium phosphorus on that young animal. Once puberty hits, if I feed high protein, she's going to waste it. Anytime I feed a heifer excess protein anywhere along, the kidney will take the nitrogen off, and it'll go out in the environment, and she'll use that extra protein for energy, but it's very inefficient. It costs a lot of calories to do that, and it costs a lot of money for a producer. But when I come out here, more of the growth is going to be fat. So that's from nutrition tomorrow. Later on, we'll talk about that, and that's where we're coming from on that. Now, this is the growth of the entire animal, and what I'm going to do now is overlay on that the growth of the mammary gland. Productivity-wise, the mammary gland is the most important part of that animal, and there's been a huge amount of research done on mammary development, mammary growth, and we basically have 2 time periods here where we have major mammary development going on in the heifer, which in the first case will affect the productivity of that animal. So I'll go through these in more detail. There are really 4 different time periods where we look at mammary development and the nutrition and growth of the heifer and how it will affect. The first one is from birth until about 3 months of age. Again, there's no particular day period here. It's about 3 months. But during this time period, the mammary gland and the heifer grow at parallel rates. As if the calf grows faster because I feed it more, or genetically it's a larger animal, the mammary gland will grow at a parallel rate. From about 3 months of age until the day of puberty, again, and I'm sorry, that line is I used the wrong color there. But the mammary gland is growing much faster. In fact, at the day of puberty, the mammary gland is growing about 3.5 times as fast as the heifer. So the interesting part of development with this animal is at the time period where the body of that heifer is growing at the fastest rate she will ever grow, because it's before puberty, but her mammary gland is growing 3.5 times as fast as she is, which is pretty phenomenal. That there are that much extra protein and calories are being shunted over to mammary growth in that animal at that time. But that's the biology of that animal. As I'll show you in a few minutes, from a standpoint of the dairy farmer, this is a critical point in time, because any effect that that farmer makes on the mammary development of his heifers, we know from the research is permanent. So if we negatively affect the mammary growth or positively affect it, it stays with that animal for the rest of her life. So economically, this is a big thing. Now, from the day of puberty until about 3 months before calving, again, the mammary gland and the heifer grow at parallel rates. So it's interesting. I can alter nutrition here, and I have no effect on the mammary gland. Back here, yes. Here, no. And then we have the last period before the heifer has her calf, where the mammary gland develops very differently. But these are two different things happening here. This tends to be the more alveolar growth. This tends to be more ductal growth. But the ductal growth has the secretory tissue, the alveolar cells that are immature, that are here, that actually are being affected. But this is a completely different type of development here. Okay, so I'm going to look at each one of these with just a little bit of research to show what's happening. This part of the mammary development has been studied. There's probably 100 papers on this. There was a lot of work done with this in the 1970s, 80s, maybe early 90s. There was a large amount of research. Right now, I only know of a couple places around the world that are continuing to work on this, because we've pretty well got all the answers, I think. But this study, which was published in 2005, is just a nice one to kind of summarize it, where they look at animals before weaning on the left-hand side, and they fed those animals in what I'll say is a moderate amount of kind of a normal amount of feeding. And this is the ratio of secretory tissue, parenchyma, to fat. And fat is one of the indicators of mammary development that we use on a practical basis. But it works actually in the basic research, shows the same thing. If I feed that animal at a faster rate, I feed more milk, I feed more milk replacer, and I get her to grow faster. And that's an interesting part of a young mammal. The more energy and protein I feed them, the faster they grow. When I do that, I get an increase in secretory tissue development. The rate is increased, not the amount at the end of the year. At the end of the animal's life, the amount's the same, but the rate is faster. So I get more secretory tissue and more fat, but the ratio is the same. So I don't affect, so it goes back to the point that the heifer grows faster, the mammary gland is parallel and grows faster. And that shows up very well. Then they also look post-weaning, and this would be like at 3 and 4 months of age. Now, post-weaning, I take a diet and I have it on a low plane of energy and protein, and that's the ratio of secretory tissue to fat. If I put that animal on a high plane of nutrition, which would have to be energy and protein increased. I changed the ratio of secretory tissue to fat. And that's the critical one here. I'm increasing fat. The fat itself isn't having the direct effect, it's an indirect effect, and it's on the secretory tissue development. And that's where I should have put, I have some slides that show this. You can actually look at the histology of those tissues, and you can see that there's something different going on there, but it's kind of hard to show with the slides, so I didn't put those in. But it does change the ratio very significantly. And this is the time period when the heifer is growing at this rate and the mammary gland is growing at this rate. So from the perspective of the dairy farmer, we have to get them to understand that later in that calf's life, the rate of gain, the rate of growth of that heifer is impacting her mammary development. And I'll show you more of the end product of that in a minute. When we look at the younger age, which would be from birth until weaning, about the year, well, let me see, somewhere around right around the year 2000, maybe 2005, there was an emphasis around the world of let's feed our calves faster. Let's feed our calves to grow more early on. And this was started, I blame it on the milk replacer companies, but it isn't all that. But some of it is the animal behaviorists were looking at, should I get this animal to grow faster? From an animal welfare standpoint, is that going to be better for the animal to grow faster? And so there was a large number of studies done, relatively large number, and this is a meta-analysis that was done in 2016. Now, one of my talks tomorrow is to show you this whole concept of how data is analyzed, so I won't get into it a lot today. But when I take a meta-analysis in today's world, I'm looking at published studies from various places, and we put them all together. It's a very powerful statistical tool to use to show us the larger effect of a particular thing, because we look at the variation and the effects in all these studies and put them together. And I'll explain that more, I hope, tomorrow. But it's a good tool to use. It's actually used a lot in human work, but it's used a lot in production animals. Whoops. Did I do that? No, I didn't do that. My computer's okay.
No, thank you.
Okay. But anyway, at that point in time, there were 9 published studies from around the world that looked at how the baby calf was grown, and then they followed those animals after weaning and kept them all the same through the first lactation. So these are not small studies. So you're looking at it at 3 years of research for each one of these studies, which is kind of expensive in today's world. So it is a lot to have 9 studies. And what it ended up showing us that really all the variation was related to the farm, was related to the study. There was only a very small amount of the of the relationship that came from how fast that heifer grew. So right away you can say if only 2% of the milk production difference at a 2-year-old was related to how the calf was grown, that's really not of practical importance. It's still interesting though, and so it's been looked at a bit more, but what it shows is that for every 100 grams of average daily gain in the baby calf would yield 150 kilograms of milk in the first lactation. So I need a research herd to find 150 kilograms of milk. From a practical standpoint, that's not very much, but it is still there. And the conclusion on that was that it's likely the effects of the genetics of feed efficiency. And we know that there is a genetic component of feed efficiency. The animal as a baby that converts energy and protein into muscle more efficiently. We now know that animal also, as an adult, converts energy to protein more efficiently. And a dairy farmer today selects a bull based on feed efficiency. So we have progressed quite nicely on that. And what this study showed was probably some of the early work on that. But in today's world, a farmer can actually just look at feed efficiency and make his genetic selection, his or her selection, and it's really interesting where we've come from. The other thing that meta-analysis showed, which gets me into the next talk, is that any of the increase from milk or milk replacer being fed is relatively small, around 20% of the difference, but 80% of the difference came as a result of the dry feed that calf was eating. So calves that ate more, are you familiar with the term calf starter? Calf grain, what that baby calf is fed for concentrate. I use the term calf starter. And I'll show you more of that in the next talk, but that had a bigger effect than milk feeding. And as we'll see, that's because the development of the rumen is taking place differently. Okay. I'll get back to this one, and this time period here, which is the most critical for a dairy farmer. And unfortunately, a dairy farm never sees this difference. You and I can't see it unless it's a controlled study, because normally on a dairy farm, all the animals are fed and managed the same. And so they can't differentiate, well, I fed these animals faster and this is their production, and I fed these animals slower and got different production. They don't do that. So this is one of a hidden problem from a dairy farm. And if you're going to be working with dairy farmers or beef producers, this is something you have to get them to understand. And again, the best way to show this is a meta-analysis. And what this is showing is optimal milk yield, looking at different average daily gains versus first lactation milk production on the left-hand axis. Now, the reason that a meta-analysis is almost essential in this kind of research is because, again, I have to take two groups of heifers and grow them from 3 months of age until puberty, and then actually at two different rates. And then I have to follow those same groups of animals, keep them all the same right through the end of the first lactation. So it's expensive research to do, and it can't happen a lot. Although in the time period from about 1995 through 2005, when this was done, there was about 20 experiments done around the world. There were 2 studies done in Italy. One was in Piacenza, and one was, I believe, in Sicily. But there's been studies done all over the world looking at this because it was a really hot topic at that point in time. But the interesting thing with that, though, and I did 2 of them, but no one has enough money to study all the different average daily gains. I can easily grow a heifer at 600 grams a day or 1,200 grams a day if I want, just by nutrition. But no one has enough money to do all those different steps. Everyone does 2 or maybe three different average daily gains. And so what this research does is it puts all of these studies together and shows you as a continuum. And one of the interesting things that we were dealing with back then, which is probably, you know, around the year 2000, so before you were born, perhaps, is that we had some groups of researchers that chose, I'll just use an example, this point and this point and this point. And their conclusion was, if I feed a heifer faster, I get more milk production, which was correct for their data. Then you had other studies that shows this point and this point. And there were several of those. And their conclusion was, it doesn't make a difference. It's the same. And then you had other ones that chose, like, I'll just pick like a point here, and then one of these points here. And their conclusions were, if I grow a heifer faster, milk production goes down. And so it was a very difficult thing for students and dairy farmers to understand, well, what's right? I'm seeing all these different results. The meta-analysis puts it together. And what it ends up showing very nicely is that you have a curvilinear approach, and this has been shown before. And there's a whole time period here from about 700 grams a day to 900 grams a day where there's virtually no difference. But every published study that looked at the high rates of gain had a decrease in milk production. So this is the one. And the interesting thing for the dairy farmer is these are the better dairy farmers. These are the ones that they care about a balanced ration, they care about getting enough protein, about getting enough energy, but they're getting too much. And so this tends to be a problem of well-managed dairy farms. You also have the same thing here of poorly managed dairy farms. Now, most of them are in the middle here. It's like anything else, it's a bell-shaped curve, but your good dairy farmers tend to get in trouble with this. And it goes back to how the mammary gland is growing. And what this slide is showing is the relationship of the mammary DNA, the parenchyma, secretory tissue. We measure it in the lab looking at mammary DNA. That's how we get an estimate of it. But looking at different time points, and again, this is the baby calf on milk replacer, I said they grow parallel. It's not quite parallel, but it's pretty close. This is the time period before puberty, and this is after puberty. But this is the one where I said it grows about 3.5 times as fast, and it does, very much so. Now to get back to that meta-analysis that I showed, which is the one here that's in white. This was a curve that we did. And we looked back in the literature, and there were 2 other times, one in the late 1980s, which used very old historic data, and then one in around 2000 from Sweden that used the Swedish Reds. It was a very different breed of cows than the Holstein. And milk production was much less, but it's interesting when I took the optimal average daily gain and graphed it with the optimal milk production and put those studies together, which were very different on production. So I just did it as a percent of the maximum milk, but all 3 of those different studies showed the same thing. So the relationship of mammary development is probably irrespective of time or breed or level of production. It's the same effect you're seeing all the way along.
Are you aware of other studies maybe conducted or lactating ruminant species like sheep or goats? Do they behave like that?
I have not seen it in other species, no. I'm pretty sure in sheep or goats they haven't. Well, they may have in the last few years, but I have not seen that. But it's most likely going to be the same, the same type of an effect. Yeah. Because the mammary development is very similar in different species. This again is one. It's a difficult one, perhaps. But what this slide is one I guess I'd like you to have in the back of your mind to try to get to a producer. And what this person did was that he took just from the top point of that curve off to the right, and just took those studies only and put it together to kind of get a regression line here. But it shows quite well of what happens is if I grow that animal about 900 grams a day, I'll call that optimal. And it was the same as what the meta-analysis showed. And as I get to 1 kilo a day, I will lose 5% of milk production. And this is first lactation and lifetime, because this effect is for every lactation. But if I get out here at 1,100 grams a day, which is not that unusual on some well-managed farms, I'm down to 85% of optimal milk. So you get these really well-managed farms that they try to do more and more, they want more milk production, whatever, and they are getting some, but they're probably losing 15% of what they should be getting. They just, on their farm, do not have a control, so they can't see that lost milk. And that's a difficult one for you as a veterinarian to get across to the farmers, but we have to work at it because this is lost income for them. But it's a real thing. The other important thing that this one shows, or it shows me, but because I know these studies, all of these studies looked at higher rates of protein feeding, because there had been a school of thought was, well, this mammary gland development may be changed if I feed high protein to this animal, and I maybe can eliminate the effect of that. And the answer is clearly no. I can alter ratio of fat to protein, and I still have the same effect on the mammary gland. So there is a biological limitation, which is probably goes back to genetics, but of what I can do with that. And there's a book, and I'm not sure if you do you take a class in lactation biology?
No.
Per se, no. Okay. There's a book that all of our veterinary schools that teach it, or animal science programs that teach it. It's called Lactation and the Mammary Gland by a guy by the name of Akers. It's kind of the main textbook that is used about that. And what he has this graph in there showing the same curvilinear effect that I showed several times, and that this was the studies done in the 1980s, 1990s, and 2000s. So the shape of that curve is the same, but it's shifting to the right. There is not data really past 2000 much, so there isn't enough to get another line here, but I would have to think that probably would be out here that we would change, and that's what we're doing with genetics. So in today's world, if I had a high producing Holstein farm or Jersey farm that has high genetics, they can probably raise they don't have to worry about 800 grams being optimal as it was in our study. It may be 900 by now. It's going to move up a little, but not too much. So that's something I think we can look forward to in your career. Maybe 20 years down the road, we can grow a heifer at 1 kilo a day and not have an effect on mammary gland. So that will change. But I think that's an interesting analogy, and it fits right back to the studies that I was involved in that showed us up here at right around 800 grams what was optimal. So my conclusion here for a dairy farmer, if they are a well-managed farm and have high genetics, that 900 grams is fine. And of course, they can't perfectly grow a heifer 900 grams a day. That's unrealistic. But you have a little range around that they can be comfortable with. Now, just for that next time period, the best conclusion with that is there's lots of different studies published around the world with low or high, sometimes very high rates of gain after puberty, and no one has ever shown an effect of rate of gain after puberty on first lactation milk or on mammary development. So once puberty is reached on a dairy farm, they can do what they want and have a lot more flexibility. And then the last time period obviously has an effect, but most of that is taken up by the genetics of that animal, and it's difficult to change this at all unless a farmer would starve his animals. In terms of mammary development out here, there's only one study I'm aware of that showed a negative effect of nutrition and management or growth rates. And that, okay. And that was a beef study where they basically starved the animals for that entire time period. And yes, they showed that it impacted mammary development, but from a practical standpoint, they're not. That's not a major problem. We're much more concerned about the body condition of that animal at that time period and the ability of that animal to calve without having difficulties. Yeah.
I was thinking about the growth rate of heifers, because if we keep the growth rate just a bit lower, I imagine that they reach the calving point being just a bit smaller, but has this an influence on the dystopia? Because we found that dystopia is linked to decrease the milk yield, approximately 3 kilograms per day in the first 60 days. It is a bit the difference of 150 we saw before. So does someone analyze the effect of growth rate in dystopia?
Yeah, it kind of confounds it. Yeah, I mean, it's a real thing, is that I don't want dystocia in that animal. I tend to look at it in body condition, but it's growth in body condition that's going to impact that, yeah. But they are confounding things, yeah. And economically important, obviously.
Did everyone hear that question in the audience?
Maybe not all. They didn't hear me.
Okay, the question was with the impact of dystocia on the growth rate of that animal, if I grow them faster or perhaps a little slower and impact dystocia, where does that fit? And it tends to be a confounding factor on the growth rates. Both of them are economically important. Dystocia can have some real economic importance. So my conclusion for you on that is that once I go beyond puberty, growth rate does not impact. I will show you some data on body weight and body condition affecting first lactation milk. But the body condition score, really we tend to use a 5-point score, which I'm sure you use. We want some extra reserves on that heifer, but we don't want fat heifers. And from a standpoint of body condition, that's where when you're out on a farm, you're going to be using body condition scoring most of the time mentally, because you're not going to take the time to weigh and measure heifers, and the farmer doesn't have data for you anyway, most often. I wish they would, but they don't. So we have to use body condition scoring, but fat heifers are a problem. If they become overweight and fat before puberty or around the time of puberty, reproduction is a real problem. If they become overweight before calving, that's when you have the dystocia problems, which are major. And major to minor on a heifer, not maybe as bad as an adult cow, but they're still very important. Can have a big effect there. Also, if we have a fat heifer, especially if they're at the point of having some dystocia, is feed intake in early lactation is down. So we probably won't get ketosis in a first lactation animal like we will an older animal, but their feed intake is still down. They're still breaking down more body fat and producing ketones. They can break down the ketones a little more efficient as a heifer and not get ketosis, but it's still having an impact on them, which is negative. So. And there's really only one study that I know published looking at the effect of body condition score on first lactation milk production, but you get the same trend that we would in an adult cow, that there's a point of where a thin animal doesn't have enough reserves to get early lactation levels as high as what we would like, but there is a point where it levels off and then goes down, and this is fat heifers and this is dystocia out here. So it's kind of the same effect, and it's somewhere around 3 to 3.5 on a 5-point scale where we'd like those heifers to be. And for those of you that are going to be bovine practitioners, you are the teacher on body condition scoring, and you have to constantly work with your producers on that. I always tell veterinarians that, because your dairy farmers see the same cows every day. And they don't understand that those cows have gotten fatter or have gotten thinner because they see the same animals every day. You have to be the teacher when you are there and say, no, this is a 3 and this is a 4 and here's where you are. And it's just an ongoing thing that will be part of your life when you're out there. Okay. Traditionally, what we have looked at is that this is looking at body weight after calving, and I apologize, this one's in pounds, but it's the trend we're looking for, and in milk production here. And I guess this is another interesting classical case of some data and how it was analyzed and how we end up with a conclusion from that analysis. So I could use this one tomorrow in that talk, but this study was published in 1986, and it's interesting. It's about every 25 years back in history where someone has looked at this. It's not looked at a lot. Because it's a big job for a geneticist to look at. But basically what our conclusion has been is that as a heifer calves and is larger in body size, these are all Holstein, that we get more milk up to a certain point and then it's basically level. So a producer needs to grow their animals to be larger on that growth curve, but there is a point of no return. But the interesting thing with this study is that they had animals in their data set, these would be Holsteins, that were around 430 to 450 kilos at calving, which we know is wrong. Management-wise is very wrong. And they kept those animals in the data set so that when they did this analysis, it pulled the line way down. I find that interesting. If they didn't have these animals in their data set, that line would have probably looked like this. And so our conclusion would be quite a bit different. But that's the way they did that.
What do you mean with body weight after calving? When do you measure the body weight? How many days?
Traditionally, this is done about 5 to 7 days after calving. So it's so you don't have the effect of the placenta, the fluids, and the calf in that. And so, but this study was done in 2020, just published last year in Dairy Science. And this one is showing a different effect. It did not have animals that were unrealistically small in the data set. They had more normal production type things. You kind of get some of the same effect here, but it is not as dramatic. This one coming back and saying an animal somewhere around 70, high 70% or 80% of mature body weight. So this data set had calving weight and also mature body weight in it, and showed kind of the same effect there, but the percentages are lower. And this gets back to dystocia a bit. I mean, of some of the other things that are going on in there. And so this slide is showing me the effect of body weight as a comparison of mature body size in production. And then over here I have culling risk. And I know many of the Italian researchers have been concerned about culling rate. We're just thinking about it more in the US now. But if you superimpose culling rate on that, how soon those animals leave the herd, whether it is in first lactation, second, third, whatever. As I go to higher mature weight at calving, the risk of that animal being culled, and, you know, for various management things or, you know, reproduction things, but metritis fits into that so great, that rate goes up and levels out at about 81%. So as the way I see this data is that from a management standpoint, I probably want to be back in here. I want to take a little, I can take a little bit of a loss in optimal milk production, which really isn't all that much, and have a lower risk of that animal being culled from the herd right away. So that's kind of a new twist of looking at that. The major conclusion is that I don't need larger and larger animals at calving, as long as they are large enough in terms of their structural growth to have the calf without difficulty. Having the extra kilos of body weight isn't as critical.
How do you explain the fact that if the body weight is higher, you have a higher culling risk? Which is this effect? Is it direct effect or is it indirect effect?
It's indirect, I'm sure. But a lot of it is metabolic. The question was, how do you explain that when the animals are larger, do you have a higher culling risk? It's probably more metabolic disease. Now all of these data would be coming from dairy herd testing associations. So we don't necessarily have all the reasons of why those animals are culled or all the particulars, but we do know that you know, it's metabolic disease that probably has a, if we get very far out here, a lot of it could be you know, calving difficulties too. But it's interesting how that alone, it can have a big impact on how fast that animal is culled. So I could go back to that, maybe I can't. Yeah. So this is one that a lot of dairy research around the world is looking at how can I manage a dairy cow, a dairy heifer, to reduce her risk of culling? And it's one of the biggest. When I look at that lecture on economics from a standpoint of the dairy farmer, the economics of heifers is huge on a dairy farm. Feeding is the biggest part of the cost of producing milk. Raising a heifer is the second largest component to the cost of producing milk. So it's big, and I don't want to cull those animals too young because she cost a lot of money to get to that point. So where do we need to be in terms of, better check my time here on you. I've gotten late. Recommended average daily gain, what's the conclusions? I'm going to walk you through an example of a 700 kilogram mature body weight animal. So it's a modern day Holstein animal in Italy. I'll wean that animal somewhere around 75 to 80 kilos. She is born at about 40 to 42 kilos, depending on genetics and a little bit of management there, but that's pretty standard, 40 kilos, 42. From weaning to 4 months, she'll get up to 220 kilos. By 9 months of age, which is when they will typically reach puberty, 8 to 10 months, but 9 is a good average. They're at that point in time, they're about 50% of mature body size. That's my MBW there, mature body weight. And it is interesting how they're within 5 kilos of 50% of mature body size at that. And then I'll go to my, whoops, I went too fast, sorry. From 9 months of age to 22 months of age, I'll grow them somewhere between 700 to 800 grams a day. So she'll have in around 608 kilos of body weight. So that 700 kilogram Holstein animal, I want her to have somewhere between 71 and 77% of mature body size. And that is a smaller number than what I used for most of my career talking to dairy farmers, because I was using that older data set that I'm very convinced had some data in it that was not good for our conclusions. So when I add in culling rate and add in the new data, this is a lower number than what we've used before. So 1 week after calving, she's going to be somewhere between 500 and 540 kilos, but mature body size will be 700. And if you get a measurement, some producers are going to have scales, which is wonderful. But if you get a measurement on a heifer before calving versus after, the difference is almost 10%. A heifer before calving, between the calf and the membranes and the fluids, will lose about 10% of her body weight on calving day. So if you look at body weight at calving, right before calving, somewhere between 550 and maybe 600 kilos of body weight is where we want to be. Now, I've focused a lot on weight, And we kind of, this is what the growth chart of today's heifer is going to look like. Always has, that's that 10% loss in body weighted calving that shows up there. I think that the point for a producer, if you're going to get them to do anything to improve their management of heifers, and part of it is looking at body condition, but the other thing is to get an idea of height, structural growth. Because structural growth is what is the end point of that animal being able to physically have their calf and not have dystocia problems with structural growth. And so having some means of estimating height is a critical part of the management of that animal. And maybe not to show you too much on that, but we know there's some good research showing us that if we grow our calves and our heifers too slow, we will have a negative impact on the production of that animal as a first lactation, based on the structural growth alone, not even looking at body weight. The structural growth does have an impact. Getting them to, this data looks at this is looking at hip height. If they're grow slow or they're too low, it's negative. Average and higher are the same. So no effect of getting them faster, but we need to have some minimal that is reached. And it also changes their survivability. And it kind of fits in the same thing that I showed you before. Those animals that if they're small, they're going to be removed from the herd faster for a variety of different reasons. And this was based off of dairy herd analysis data, so I don't have all the reasons, but we can pretty well suspect it. The thing for your producers are they need to realize that by the time that animal is breeding, she needs to be about 80% of mature size. So when in a pen of heifers that is a breeding pen, they need to have some sort of marks on a gate or a wall or somewhere that shows me 70, 80, 90% of mature body size, and I want those animals to be around 80%. The other thing is by calving, I want them 95% of mature size for height, but weight is going to be 75. So they're different animals that you're looking at here, but that's a key thing in terms of structural growth that the data is really clear on. I want her to be structurally mature at calving, not necessarily having the body weight. So the conclusion there is you go into a herd that you're working with, and I'll say they're group fed, they're on a total mixed ration, and they have first lactation and older animals all in the same pen. You should not be able to look across those animals and say, oh, that's an older cow, that's a heifer, that's an older cow, that's a heifer. You shouldn't be able to do that. They should look all pretty much the same. If you look at body weight, yes, you can tell, okay, this is an older cow, she's heavier, this is a younger heifer, but size should fit in well. Whoops, oh, thank you. A couple last points and then we're late for a break here. I told you I talked too much. But there is a thing in heifers called compensatory growth. It works in all mammals. And basically, this is back to my growth curve here. But if I take an animal, or you're on have one of your clients has a group of animals that they haven't grown well, they're small. This is genetics, the genetics of where that animal should be, but you look at those animals and they're small. A mammal has the effect where I can take, at that point in time, I can increase the density of nutrients in their diet, which is not just protein, not just energy, it has to be increased density of nutrients of everything. And that animal can compensate. It's amazing. They will grow very rapidly. And basically because that heifer is trying to get back to her genetic set point, and they will do it very efficiently. Before puberty, they will do it extremely efficiently. After puberty, it's a little slower, but that's because the growth rate is going to be slower anyway. But if you're working with a client and they've made a mistake and they haven't done a good job, or a classical one in some parts of the world is they put them out in pasture and they have some very poor forage quality for a while and they just don't grow, they can get them back in a relatively short time period, which is again where you can help a producer get back on track and get back economically on their heifers, if you can catch that and work at that. But here you would need to have some data on how tall they are or what their body weight is. But you can do it, and it works very efficiently. On the other hand, you get a producer who decides, I'm going to grow, the classical one is I'm going to grow my baby calf faster. Instead of feeding them 5 or 6 liters of milk a day, I'm going to feed them 10 or 12. And you can do that. I mean, you can feed a dairy calf or a veal calf. We can feed them lots and lots of milk and they'll grow really fast and get up to a much faster body size than what they would typically be for their age. And then the interesting thing is that calf will self-impose compensatory growth, and she will grow at a slower rate to get back to the genetic set point. And there's some real interesting research related to that where people have the animal behaviors. I pick on them some because I understand what they're doing, but sometimes they take it a little too far. That's my synopsis. But they look at growing those calves faster, feeding them more and growing them faster, and they do that very well. But if they look at the growth of those animals at 4 months of age or 5 months of age, they're exactly the same as the control animals in those studies. And that's a consistent thing, and it's because of compensatory growth. They simply will reduce feed efficiency. They will not be very, they'll waste more energy and protein here because they want to get back to that growth point. The other thing for you to look out for when you get in practice is that there are feed companies that will say, feed my product X, Y, whatever product it is, and your heifers will grow faster and they will be larger. Well, I can feed something, especially if it has protein and energy, and I can get them to grow faster. But I can't take nutrition and change mature body size. It doesn't happen. I can change the rate that she grows, but I can't affect maturity. The only way that I can affect maturity of an animal beyond genetics is with severe health issues. So yes, if she has severe respiratory disease for a prolonged period of time, she will not grow as large as she should. But nutrition can't do it, only health. So this is I think my conclusion here. Never in today's world, never grow a Holstein more than 900 grams a day. That's really the maximum before puberty. For a Jersey or a small breed animal, that would be 600 grams a day. You don't have many Jerseys at all. Yeah. We're getting to where upwards of 20% of our dairy animals in the U.S. are Jerseys because they have higher fat and higher protein. Beyond that, basically getting beyond that is going to cost money. When I look at that calving animal in today's world, and I'll show you a little bit of this, but I really don't want 24 months for a Holstein or Jersey. I really want to look at 22 months of age from a management standpoint. And again, when a dairy farmer looks at economics, the biggest way that he can affect the economics of that individual animal is age at calving. And we traditionally use 24 months, but it really needs to be 22. Actually, an Italian data set from the 1970s was the first to show that from Piacenza that calving at 22 months of age is the most economically important age, and for probably 20 years people just ignored that data set, and it's very correct. And this is typically what you see for Holsteins in Pennsylvania, and I've looked at enough data from Italy when I was in Bologna that it's the same here. We trade genetics around the world, and our management's pretty much the same. So I can go in an Italian herd and it looks just like a Pennsylvania herd. It's no different. And in fact, the bulls are the same. Yeah, it's amazing. But this is looking at number of animals here and age at first calving. And this is what you have genetically and or management-wise. We get 22, 23, 24 is the highest. Actually, in 2020, in Pennsylvania, we had more heifers calving at 23 months than we did at 24. And I suspect that's the same for you. And we have a tremendous drop off here. There's my arrow. This is just a good synopsis of the endpoint of that heifer, is that we don't want heifers calving at 20 months. Because that's calving difficulty, that's dystocia, that's all sorts of problems there that can happen. So milk production will be down on those animals, very likely. Some animals are calving at 21 months and doing very well. And I've seen that also in Italian herds. But typically 22, 23, and 24 are the best. They can calve out here, but what I'm going to show you in the next slide is actual first lactation milk production of these animals. And it's a flat line. So this is virtually flat. If I showed the standard error bars in here, they all overlap. So numerically, these are slightly higher, but on a practical basis, it's not there. It's a flat line here. So if you have a producer that's calving at 22 months, they're making this much milk. If they keep them in the heifer barn, which costs them €2 to €3 a day, up to 28 months, they make the same amount of milk. So it's easy to see which one is going to cost more money to get her to calve. And that's been the driving force around the world to get calving younger. So now we better stop and have coffee. Right? Sorry.
Avvisiamo tutti quelli che ci seguono da casa che adesso ci sarà una pausa, like 20 minutes, 15 minutes.
Yeah, whatever.
Una pausa di un quarto d'ora, 20 minuti e poi si riprende.
We started
Let's go.
Yeah, now it hasn't caught up with, no.
This thing, the microphone is here, but the quality is very bad.
Okay. Yeah, if you're okay. Now,
It's okay,
it
fine.
hasn't caught up with, there you go. Or what I did.
It's not synchronized.
No,
Okay, we can.
I did something to it when I switched,
Okay, because you are no longer, I could, now we are no longer, start with the last slide, but fine, then we have to stop sharing, and then we have to go back to sharing again. Or we can leave this right now.
okay, yeah,
We can leave. Share, we find your your, where is it? Your presentation here. So let's just share this one. And then, okay.
Okay.
Mi amore che ancora non mi ha risposto da ieri, ho dovuto
Chiamalo. Allora, difficulty loading, allora, ok. Allora, dunque, let's go back to sharing.
Yeah, I tried that and it didn't work.
We go window, room and development or hyper growth? Room and development. You want the very first or
The very first, yeah.
this one?
Yeah.
Okay, perfect. Room and development. Okay, so we choose this one. We start the presentation. Okay.
Now, do we do another break or just keep going?
We do expect to be done.
With this one, I'll try to keep 30 minutes
30 minutes, and then you have.
and then go to health and nutrition and
Now,
then
now we can go.
you may have to help me after this one to get the conversation over.
Va bene?
One thing before we start again.
Sure.
Okay.
I reminded the graph before about the role of the item in the compensatory mechanism. When they deviate from the basal lines, okay, this is the moment in which the fat parenchyma ratio is altered.
It's also, right, yeah. So that's a confounding effect on that one, and that would be a bad way to do it. Yeah.
Okay, so we saw that they profits and at the end of the pro they reach the same point.
Right,
So watching them 10 minutes, okay, aware of something got wrong in the wrong phase. So how can we farmers would be able to monitor
No, yeah, they're probably not going to do that, right? But they will at breeding time, and they will at breeding and calving. Will be the two time periods.
What happens before that they are not aware of this? I don't know, maybe some technique of machine learning, right now recording of recognize every factor in the puzzle and make a machine learning.
I mean, there is a technology to do it. Yeah. But we are not going to have it. Oh, yeah, yeah. There's some good research on that, yeah. Yeah.
I was just wondering, I'm sure that others have already investigated, but what if we take the metabolic weight instead of the body weight, the relationship with the all those graphs, maybe the relationship wouldn't be
You change the slope of that. It's still there. I've never pulled that one out with the metabolic. Some of the physiology and some of the management, you know, is trying to put together. Because for the most part, they, you know, they don't get out, they haven't been out working with at all. They work.
We have there are not enough jobs as vets in their area because our agricultural sector needs.
Yeah, oh yeah.
It's hard.
We have more male students than
Or
yeah, our veterinary class is 90%. I'm saying
but it's not just this today, or it's a particular, usually our classes are 80%. That was reversed, I mean, when I was a student.
oh, sure, yeah, it's just a trend, yeah.
And I want to even working with since we have an exam, we have a test, and they said, okay, female students are again, so they can learn the university because I wanted to test this year, and we
What we're finding is that on our undergraduate program, I mean, I'm in science, but for the university and for our College of Agriculture, the entrance are female men don't want to go to the men go get a job and make really good money.
Yes, more than
So it's just like a trend now. They want something that's short-term gratification,
human medicine. That's not the same ratio. More ways.
But that may change too, I don't know. Yeah.
And I read that first year I was there as a postgraduate student. 90, and several years later, like 97. So, so you must have started with
No, yeah. He's 98. Yeah. And you do He's actually the associate. He's the associate dean of Penn State. Yeah.
and there was a bit of
Okay, we can go, all right. Okay, I'll let you.
They still want to see you. To show them.
Okay, all right.
Okay. If you want.
Okay, we'll continue on with rumen development. I'll go a little bit faster now so I can get through. And for you and I, when instead of looking at that dairy calf, we're looking at this. When I see a dairy calf growing, most people see this nice, cute little calf here. But what I see is a rumen development being developed, and that's really what we're after here. And so what I'm going to try to do here is describe the process of rumen development, which is, obviously very unique, and some of the management that can affect it, and just try to show a little bit of the histology, what's going on. Okay. And in terms of for the dairy farmer, the number one most important thing when that calf is born is colostrum, which I'll talk about tomorrow. The number two thing is rumen development. It's really the second largest thing, and I'll have a quiz for you here. I've got, this is actual data from a research project, and it's not a unique research project. There's many of them showing the same thing. But you take two calves and you grow one at a relatively moderate rate or a standard rate, which is the blue lines. And then I grow one faster because, like any mammal, the more protein, digestible protein and digestible energy I feed them, the faster they'll grow. That's just a standard thing for mammals. And so we have these two dairy calves, one that grows at a very fast rate, one that grows at a slower rate. And so I always, ask the question for you, and we'll come back to this later, but which calf is better? At weaning time, which in this case is 6 weeks. Do I want a big calf or a small calf? Now I'll answer that later. Okay. Now, if we look at the development of that calf physiologically, at birth, the rumen makes up about 25% of the physical capacity of the four stomachs. The abomasum is 60% at that point. See if this is going to work. By 3 to 4 months of age, the abomasum has continued to grow, but at a slower rate. The rumen has grown at a faster rate. It now represents about 65% of the physical capacity. And then by the time that animal is mature, the rumen makes up about 80% of the physical capacity. So the rate of growth of the rumen is obviously much faster. All right. This would be what that animal's looking like, and I don't know where you've gone on dissections, but this would be a newborn calf, 4 stomach compartments. The interesting thing, if you can kind of see from the rumen tissue there, it's very, very thin at this point in time when they're born. At birth, it would be sterile. That changes very rapidly after birth, but at birth it's sterile, and just no fermentation going on at all there. By 3 months of age, this is what it's going to look like histologically. And any of my slides where I have this, I put a ruler, which for me is 12 inches. So just to give you a size so that you can get an idea of what it is. So the rumen at 3 months of age is very large. This is where diet has an effect. If I feed this calf only milk, the rumen is going to be pretty small. If I feed this calf and at 4 weeks of age, look at milk and some sort of concentrate, the rumen is larger and darker in color. And the color is a real thing that I'll show you in a few minutes that has an effect there. But it's dramatic, the effect that I can have on nutrition with this calf. And again, this is going to change over time pretty rapidly. If they're on milk and some sort of concentrate, how fast that rumen size will develop. The more important point is looking at the internal compartment, and what I'm looking at are the papillae. And this would be like maybe a 6 or 8 week old calf that has a well-developed papillae, just what they're going to look like from the surface. Here's what they look up like closer, and this is, to me, is the more interesting part. Now, these would be the papillae of a more mature animal. These were actually a heifer that was maybe 14 months of age, so it'd be a mature ruminant in terms of developed papillae. Okay. Doesn't like something one time. The interesting thing for the dairy animal, though, is that we can actually just with looking in the microscope, we can see why the papillae are so critical, because the capillaries are really very close to the surface, and they're all over these papillae, and they're so critical in absorbing acids and getting them into the bloodstream, which is how this adult cow can produce 40, 50 kilos of milk a day and get the energy and protein she needs, mainly energy in this case, because she can produce a large amount of acid and absorb them very quickly. It's really the ultimate part of the dairy cow that gives her the ability to do what she can do. And I have a bias. I mean, you'll probably work with many different species, but the dairy cow, today's dairy cow can produce her body weight in milk fat, which is a highly digestible energy source, and she can produce her body weight in milk protein, which is a high quality protein, and do it every year. And she's the only species that can do that. A chicken can beat her, or a pig can beat her, but they can only do it once. A dairy cow can do it year after year after year, and this is the component of her physiology that allows her to do that. Now, what I'm going to show you is some slides. This is the rumen wall of a newborn calf before any feed is given to the calf. We've done a lot of different students over the years looking at rumen physiology and development, and so I put some of these slides together for you. And so what I have here basically is the epithelial cells, which are very rapidly growing like the small intestine. They go from the baseline to here in 3 to 6 days. So very, very rapid growth of the cells, connective tissue, and then submucosa. And what I'm going to show you is a series of slides that were taken at about 4-day increments from birth on, but they were 4 days after feeding starch. So we took these baby calves, they were being fed milk, but we also force-fed them starch, 500 grams of starch a day from day 1. So I can show you the effect of starch. And this would be at 4 days of age, and you already see some changes in these. It gets down to 8 days, and by this point in time, they look like an ovine in terms of the shape of the rumen. A dairy cow's rumen are round, and a sheep's is going to be more pointed. But that's but you already see some of the development of the submucosa in these in a very young age. And then again, another 4-day increment. The other thing that you're seeing here is it's these cells that once they get at the edge are being sloughed off. That can be a management thing that can have a negative effect later on, but that is what's happening there. And by the time you get to about 21, 28 days, the capillaries are already, this would be 21 to 28 days in that range. Capillaries are already there. So it's just it's a tissue that rapidly develops under the right set of circumstances. And I just think that's an interesting one to see. It's one of the tissues that develops as fast as anything in that young animal, but the small intestine would do the same kind of rate of development. So at birth, these papillae in terms of length are going to be less than 1 millimeter tall. By 28 days, they're easily 5 to 7 millimeters. And the key thing there, though, is they can have the absorptive area for VFA, for absorption of nutrients, is going to be greatly enhanced when I start having all of these papillae there to do that. Now, in terms of bacteria in the rumen, they establish within the first few hours of life that animal will have bacteria in there. But in order to get bacteria to get a normal development in there, we need a low pH to get that to happen. And it's kind of interesting when I'm looking at the calf, in order to get the bacteria that digest grain concentrates more, which is the amylytic bacteria, they require a low pH. If I want to get fiber digesting bacteria, they're going to require a more buffered pH. That's the same as an adult ruminant. The adult ruminant has to have a more buffered rumen in order to digest forage, and the calf is going to be pretty much the same. Now, when we look at Vfa production in the rumen, there's three major Vfa sources in the ruminant animal. It should be acetic, propionic, and butyric. Acetic is the end result of fiber digestion because of the fibrous digesting bacteria. Metabolically, acetic acid is their end product, whereas the amylytic bacteria have a primary end product of propionic and butyric acid, and their source of nutrients that they digest is sugars and starches, our sugars and starches. Now, in all cases, these various short-chain fatty acids will all end up having and being an energy supply for the animal. Acetic and propionic serve as a good energy source for the animal. They're absorbed through the rumen wall in those capillaries. They go to the liver and get converted to glucose. Initially, that dairy calf is going to be using more lactose for energy, the liver, but the liver very quickly converts to taking these ketones and converting them into glucose. Actually do it very efficiently. If I take a dairy calf or a dairy cow, though interestingly, I get this animal on a mixed diet, so they're getting some sugars and starches and some forages. If I take a blood sample from that calf or cow, I can easily pick up acetic and propionic acid. Acetic and propionic are going to be absorbed, it's said, in the rumen wall. I can pick it up on its way to the liver, but I can never pick up butyric acid. Butyric acid, if it is in the blood of an animal, is going to be beta-hydroxybutyrate, which, again, we measure that in the lab, and you've measured that lots of times probably, yeah, of looking in the blood, but you'll never find butyric. So normally acetic acid goes into the portal blood. It's used very efficiently for growth. If we look at the secreting mammary gland, acetic acid is part of milk fat. About half of the acetic acid that a dairy cow produces in a rumen goes to the mammary gland and is converted to milk fat. So that's one of the reasons why fiber has a huge impact on milk fat production in a lactating animal, because of that direct effect. Propionic acid is more efficiently used, also gets absorbed in the portal blood system. It's used for gluconeogenesis, and it would be growth or production. Interestingly, butyric acid that is produced in a lower percentage of the total here, butyric acid is typically around 10 to 15% of the total VFAs being produced, but that is used as an energy supply for the rumen. And let me see, I probably, well, I'll show you the diagram for this in a minute, but from an evolutionary standpoint, the rumen has developed so that it has its own unique energy supply, different from the rest of the animal. And so what happens here is that I'm getting the developed rumen in this calf. She's producing acetic propionic and butyric acid. And when these go into the portal blood system, every growing cell in that calf's body is competing for that energy. But when she makes butyric acid, it is converted to glucose, to energy, not glucose, sorry, but it's converted to energy in the rumen wall. And so any butyric acid that rumen produces, the rumen has exclusive use of that energy and not the rest of the animal. Now, if we look at what's happening in the pH of this, is that if you take, this is time relative to feeding on young calves and on going from 1 week to 6 weeks of age, if I measure the pH of the rumen, when I feed that calf any calf starter, the pH drops way down. It's easy to find a pH of 4.5 or so in a young calf, and it's rather typical. What would you think in an adult cow if you had a pH of 4.5? She'd be very close to being dead. Okay, they don't survive well with a pH that low, but with a calf it's actually pretty typical. And so they can have some huge fluctuations there, because what's happening there is that the first few weeks of life you have some very active bacteria there that can digest, take amylase, sugar and starch very quickly, but they don't have the absorptive capacity like an adult cow is to absorb those VFAs through the papillae, because they haven't developed yet, or fully developed yet. And so you get these dramatic drops in pH. But that's normal. That's actually normal. Early on, this would be my diagram of the forestomach capacity. When she's digesting milk, it's only occurring in the abomasum. Nothing's happening in the rumen on that. When I have forage in there, she's making acetic and propionic acid in the rumen. And when I add grain in there, she's making propionic and butyric. The other interesting thing that fits into the development of the dairy calf is there's been some interesting research showing that some of that butyric acid that she produces in the rumen actually goes off to the small intestine and has the same positive effects on development of the small intestine tissue as it does in the rumen. This is the one this is the diagram of butyrate metabolism in the rumen epithelial cells. Oh, and it's another case of, this was first shown in 1979. That was the first time we really knew why. We knew it was happening from the older literature, but we didn't know why. And this was the first time it was published of how the bacteria can take butyrate, and we can convert it to beta hydroxybutyrate, where I might find it in the blood, but it also can take a side shunt here and go through a different cycle and make energy. And this is what the rumen wall actually does. So when a dairy farmer feeds grain to a calf, which has starch in it, he's effectively only feeding the rumen wall, or first feeding the rumen wall, and it's not until this is saturated before it starts making beta hydroxybutyric acid. And so it's one of those wonderful things that a farmer can do management-wise that has an impact that they don't understand, but you do, of what they're actually doing, but they're developing the rumen wall, and the rumen wall has exclusive use of this energy, the animal doesn't. So it'll grow, that's how it can grow so fast. And you know, basically grain has this effect. And I purposely show in my pictures of a calf starter, and you will find this in the field quite often. You can have whole corn, whole oats, you have whole grains in there, and they're very well digested by the calf. Management-wise, if I were to feed this kind of a diet to an adult cow, because of the volume of feed that she would eat and the rate of passage in the rumen, this corn would end up not being digested in the rumen or the small intestine or the large intestine, and it would be in the manure. But interestingly, the calf does a very good job of digesting whole grains. And that was first done in about 2008 or 9 was when I had a student do some of that early work. But it just, this is just some slides of rumen walls at 4 weeks of age, 8 and 12, of just the comparison of with starch and without starch. And so the management effect in here is pretty amazing. Now, to give you a hint on the answer to that question of which calf do you want, the bigger one or the smaller one, the calf, like any growing mammal, will only be able to use so much energy and protein. And if I give her all the energy and protein from milk, she will not be in this category, she'll be in this category because she'll be very satisfied. There are two things that satisfy the calf diet-wise, same as you and I, it's volume and energy. And so when I feed lots of volume of milk, lots of energy of milk, I shut down the brain to get that calf to eat more. So she's going to be in this category here, not eating grain. If I don't satiate her energy and fat, she'll eat more grain and she'll be end up in this category. It's pretty phenomenal. I have lots and lots of pictures of this, but it's a phenomenal. If I have a calf that's eating greater than 1 kilo of grain, just the difference in the size of these rumen papillae from those animals versus one that's not eating very much grain. It's a dramatic difference. So for research, it's fun to do research on this. Management-wise, though, it's easy to see where the absorptive capacity of an animal with papillae this big is so much greater than the absorptive capacity of those. But quite frankly, there's very little research measuring absorption of VFAs because it's hard to get blood samples. I would have to get blood samples down here in the rumen, and it's just impossible to do. So you have to kind of take some of this based off of the histology and not the blood data, if that all makes sense. So basically, from a management standpoint, rumen development happens because of butyric acid, primarily, a little bit of propionic, but primarily butyric. And it takes about 3 to 4 weeks of concentrate of starch to go from that small papillae to the larger ones. And that's a pretty good range for a practical scenario. From here to here is about 28 days of significant starch. This is one I won't focus too much on. Yes?
Is there any effect of the treatment of grains, like heat treatment, or are you seeing any effect on the growth?
Not really of the calf. I want whatever starch goes to that calf, I want the starch to be digested in the rumen. I don't want small intestine like I would for a lactating cow. Protein-wise, the effect of slowing down protein digestibility is not beneficial either. The calf diet can be pretty standard, pretty simple diets in terms of.
I mean, like flake corn, like heat-treated corn.
Oh, if it's basically from a standpoint of the difference in digestibility of treating corn in different ways is almost none. So the dairy farmer can do as well with whole grains versus highly processed grains, and they're cheaper. There's a little bit of data to show that if I process the starch to make it rapidly digestible, actually has a negative effect because it drops the pH faster. As opposed to a lactating cow, I want more of it to be digested.
They are on the market for beers are usually like processed with they get paid,
Yeah, we tend to do that. The industry tends to do that some because we know that has a positive effect on the lactating cow, but it really has almost no effect on the calf. But there's always an age-old question, and I don't think I'm going to take a lot of time to spend on this. But a dairy farmer or a dairy researcher is always asking, do I feed forage to a calf before weaning or not? And it's an interesting thing that the answer is it depends. Sometimes we can see a positive effect if we feed a small amount of forage, but it's really quite small. And for today's lecture, I won't get into the detail on that. Only to say that if, on a practical standpoint, if you look at the development of that rumen, it's very small at birth. It's growing up to 3 months of age very rapidly, but it starts off very small. And when I look at the energy density of forage as compared to the energy density of concentrate, it's very different. And so if the physical limitation of the rumen is a problem, I want to feed a concentrate because I want more energy and more protein in a smaller package of feed, where forage will dilute that out. And from a management standpoint, when you get out on a lot of Italian farms, and I see it in US farms, but more in Italian farms, a dairy farmer typically will feed the same unifeed that they have for their milking cows to their baby calves. That you've seen that before. Yeah, it's very common here. And the protein percent in the unifeed for a milking cow and the protein percent in the diet needed for a calf is about the same. But the nutrient density are completely different. And so we take that young dairy calf on an adult cow unifeed with lots of forage, and they can't eat birds. They can't eat enough to get the nutrients that they need, and they don't grow well. So it doesn't work well, but it's tradition in Italy to do that, and it's needs to change, but it hasn't in the time I've been around here. So this is an interesting one, but the other interesting thing is you go to some parts of the world where they don't have a good access to corn and soy or canola. They don't have, it's too expensive or not available. They feed these young calves forage, and it's interesting if a calf is eating a very lush grass, it's full of sugar and starch. And sugar and starch is what drives the butyric acid production. So it can't, if it's done correctly, they can use a forage and get it to work, but it's an unusual situation to get that to happen. It doesn't happen in Pennsylvania, and it doesn't happen in Italy that way, but it does if you're in Central America or parts of Africa. So I'm just going to add a couple slides because tomorrow I'll cover more calf feeding thing. But to me, the goal for a dairy farmer, because of the physiology and the histology changes in the rumen, is that the first week of life, and I didn't change it, it's about 4 liters of milk a day. Maybe move it up to 5 or 6 liters, but no more than that. And I want to reduce the milk before weaning because I want to encourage grain intake. A calf is going to be satiated on dry matter and energy, and so if she doesn't get it from milk, she'll try to eat it from concentrate. On a practical basis for the dairy producer, I want them getting some sort of grain into that calf very early on. And they need to be able to be eating substantial amounts by 3 weeks of age, because in today's world, we're going to try to wean that calf off of milk or milk replacer by 6 to 8 weeks of age. So it takes 3 to 4 weeks of a calf eating starch to get rumen development. So I want them by 3 weeks of age to be eating starch so that I can wean them by 6 weeks or 8 weeks. And so that's the management behind it, because we're always playing that tightrope of trying to get the calf to grow fast, but also to get the rumen to grow fast. And we can't only maximize growth of the animal. We have to remember that the rumen is a functional part of that growth. So I want a half a kilo of grain for 3 to 4 weeks before I wean a calf. And that's a critical management thing. If you pull all of that rumen development data together, that's kind of the conclusion for it there. We need a certain amount of starch for a certain period of time to get that to work. And then from a behavior standpoint, it's usually best that a producer gradually wean that calf off of milk over a 5 to 7 day period, because you're having a huge behavior change when you take an animal from a liquid milk versus non. And it can have some real negative effects. And the producer that does a really bad job, it can easily cost them a month in age at breeding and therefore age at first calving if they don't do a good job on developing the rumen. So there's a real economic standpoint. A month of delayed growth in today's world is probably 100 euros. 80 to 120 euros in most parts of Italy. So economically, it's an important thing. It can also stress the immune system. Here's a case where if you get out on a farm and the producer has serious, often respiratory issues in their dairy heifers that are 3 and 4 months of age. It often shows up in respiratory disease. It may be other disease, but respiratory is the largest one. It can be because they've really stressed the immune system by having a poorly developed rumen, which again is going to be economically important for them. Now, we've known for a long time that the more, this is looking at milk replacer concentration or the amount of energy and protein I'm getting from a liquid feed versus not. This is the grain dry matter intake, calf starter, whatever, by week of age. And this is on a percent of live weight of the animal. So in today's world, we typically feed a dairy calf or recommend they get about 12%, at the most 16% of live weight of a liquid feed a day. And that gets you into these categories here. And if we feed that animal at a higher rate of milk or milk replacer, what happens is we delay intake because of dry matter and energy being satisfied by milk, and they don't have their appetite is suppressed and they won't eat the grain, and so they will eat that slower. And we've known that for a long time, but you can easily see this on a dairy farm, and it's just very striking. Now, and I'll come back to that point in a minute. I'm giving you all the answers to the quiz, but just in pieces. If I look at the pH of that developing rumen, by 5 to 6 weeks, we can get, if we have lots of absorption capacity with those papillae, we can buffer that rumen much like we would think of with a heifer or an adult cow. We don't end up with the really low pHs, but at week 4 we can easily get very low pHs. And we can also get acidosis in these young calves. Just like very similar to acidosis that we would have in an adult cow in many respects. But it's not quite like the adult cow. It's a little bit less for the adult cow. You know, if I have anything that gets down much below 6, I have acidosis in a cow, where the calf can be much lower than that, and it's still going to be fine. But if we see a calf somewhere from a month of age to even 3 months of age, if they have acidosis, it's defined really as anorexia, lethargy, and diarrhea. This can happen in a beef calf or a dairy calf. You'll also get abdominal discomfort and lack of rumen motility. And these will be things that you can pick up when you do an exam on those calves. But it does happen in a calf. And it's very often on a farm, you'll observe it 4 to 6 hours after they've given grain to those calves is when you'll have it. The other interesting thing this is what's really happening here, that the rumen pH is somewhere between 5.5 and 6.5 before feeding. This is time relative to feeding here. I feed that animal, And the amyloidic bacteria, whoa, I touched something. What did I do?
I think that's yours.
No, I put my elbow here.
No, but
I don't think I touched that, but
Il proiettore, credo. Maybe that went on stand.
oh, okay, all right. I won't touch that again.
No, but I think, I guess it's a question of time. You know, after a certain time, it goes on standby.
Okay, okay, all right. But what happens here, if I don't have good absorptive capacity, is that pH stays down here longer, and it will influence that calf. A dairy farmer will also see this sometimes as this is the calf that with a low pH doesn't eat grain tomorrow. And you'll have a producer tell you sometimes, well, my calves, if I feed them grain every day and I'm feeding them milk and doing this, one day they eat grain, the next day they don't, and it's up and down. That's acidosis in the calf. They're getting grain intake today, producing a lot of acid, but they don't have the absorptive capacity of the rumen to get that acid out. The calf is uncomfortable and it doesn't eat grain the next day. So that's something you know, on a practical basis you will see. Also, and that up and down will basically take that calf and stress them to the point of where it can stress their immune system and increase the chance of respiratory disease, which is usually the first one. And it's kind of interesting with the calf. This is some research from Spain. Yeah, it's getting dated, but it's a good study. And this is actually 6 liters and 8 liters. I moved this one around, or I changed the units for our producers. But it's kind of interesting, the cutoff of where you affect grain intake early on in that calf is right around 6 liters a day. If I take today's Holstein calf and feed her at 6 liters, she will eat a lot more grain, and it happens about 30 days of age. And then there's a bunch of other research that shows pretty much the same thing. This is just a good classical way. If I keep her on 8 liters a day, I satiate her intake and energy and fat to the point of where I have a big effect on grain intake, because that's what I'm measuring here, grain intake here and day of study. So does this slide make sense? Sometimes I'm worried I go too fast and I'm not showing you my axes.
What's the age of the calves?
This would be 30 days.
And the age of the calf?
Age of the calf, 30 days. And that's about, if I feed a small amount, a small or average amount of milk or a large amount of milk, for the first month of age, they don't eat a lot. It's really after 30 days of age that grain intake will change, and that's where it's really critical. So if a producer tells me I want to feed ad libitum milk, and they're very sure they want to do that, I say that's fine, but at 30 days of age, you need to stop that. Because management-wise, I'm going to prolong rumen development if I don't. And that's where you can have that big effect, and it works out to, that's about 500 grams difference there in grain intake, which has that huge effect on rumen development. And if you ever want to teach rumen development to a producer, I can do this in the US and I'm not sure if you can. But if I'm going to do like a workshop on rumen development for dairy producers or feed industry, I will get someone to raise 2 calves for me, one that is on all milk and one that is on milk and grain. And I typically get a veterinarian to go ahead and get me, kill the calves and get me 2 rumens. And if I show those 2 rumens to a group of dairy farmers or feed industry people, it is so dramatic. It teaches them the lesson very quickly. For us, bull calves aren't worth much, so we can do that pretty easily. It doesn't cost a lot of money. But the visual and the smell difference, because the smell-wise, that calf if I'm looking at a rumen that has only had acetic and mainly acetic acid production, or no acid being produced, doesn't have much smell. If I get that calf that has had grain and I'm getting butyric acid being produced, it really stinks. And they will remember the smell of butyric acid. It's very dramatic, but it's a good way to teach the point. And I've kind of covered this, but if I take that calf at weaning time and she's eating very little grain, I'm going to wean her. She's a larger animal. She'll eat a lot of grain, and that's where she eats grain one day, gets acidosis, doesn't eat grain the next day, and they have this up and down effect that has a big impact on their health. And it's just the difference in a rumen like this or a rumen like this in terms of their ability to absorb VFAs. So to put it on a perspective of growth, if a farmer has, this is the growth rate of his calves before weaning, and this is after weaning, if their growth rate keeps doing this, they're probably healthy. They probably have a well-developed rumen. If their growth rate does this, which is very typical, can happen, it means their health may be compromised, but they may be very healthy calves and they just have very poor rumen development. And if they do this, they're either unhealthy and or have bad rumen development. I remember, I've been on many farms where if I'm trying to get my point across to them, is that you get a weigh tape, which I didn't bring one. You all know what a weigh tape is? Something that I can put around the heart girth of the animal to estimate its body weight. That's a typical way. You'll probably end up having one if you get out and work with dairy farmers, and you tape the animals in their calf hutches or wherever they're feeding the milk, and you get a couple body weights there, and then you go over to their first or second group of weaned calves over here, and you weigh them, and you put a weigh tape on them, and they're the same body weight, and that happens a lot. You have poorly developed rumen, and so basically the time period from here to here, they're losing it, and it's costing them money. So it's a nice way to measure that, but that's really what's happening. So to get back to this question, if you have a calf that's growing but at a moderate rate, with a reasonable amount of milk, which what this was, like this one?
Here?
Yeah, I gotta get that. Okay. Or I feed a calf all the milk they want to have, ad libitum milk, and she's growing at a fast rate. Which calf is best? Blue or orange? Do I want great big calves at 6 weeks of age, Or do I want average size calves at 6 weeks of age?
Questa è un più di meno di valutazione.
I need to see the after weaning.
Pardon?
I need to see the after weaning.
Yeah, I don't want to show you that yet. But the answer is I'll go ahead and show you that. This is after weaning. And this has the average daily gain. But what happens, first of all, when I have an animal that's on a high level of liquid feed versus solid feed, there's a huge behavioral change the first few days. This animal doesn't know how to eat anything else other than milk. But following that, the average daily gain of an animal that was real high here is always going to be lower here because it didn't have a developed rumen. And it takes a long time to catch up. And typically what happens on these farms is the control calves, which are the blue ones, over this time period up to 12 weeks will have a higher average daily gain than the younger ones will. And it's because of the rumen development. And what's happened here is that we've had an expensive diet versus a cheaper diet. Milk is always going to cost more on a standpoint of kilos of energy and kilos of protein than grain will. And so you change the management of it, but the end result is going to be pretty much the same. It just costs them more money. And what you'll end up dealing with, though, is you have an industry out there, a milk replacer industry, which is promoting sales of milk replacer. And so they're promoting the farmer to grow that young calf faster, but they usually don't show them the results only up until weaning. They never look at it after weaning, which is where you need to work with the producers and show them the overall effect here is at 4 months of age. That's the important part, not just up until weaning time. Okay, is any questions on that? Did I cut rumen development down pretty fast, but this is one of my most favorite personally slides. This is rumen papillae development at 6-week-old calves, fed milk and forage, which made acetic acid, or milk and concentrate grain, which made butyric acid. And the difference is so striking. Any questions? No. I need to somehow get to my next talk here. Oh, yeah, the other thing that kind of gets into the next, when I talk about feeding the older calf, when she has a developed rumen and she's making butyric acid, to make butyric acid, she's growing bacterial protein. And bacterial protein is 50% plus or minus 5 crude protein. It also has a really high biological value for that growing dairy calf. If you look at the essential amino acid composition of bacterial protein and muscle tissue, they're almost identical. And that's what we mean by the biological value. It's the amino acid composition of a diet relative to what that animal needs. And rumen microbial protein is almost a perfect match. And it's actually slightly better than milk protein for biological value for the calf. So it's really efficient. And once the liver is adapted to using ketones versus lactose sugars at converting energy, that's actually even more efficient. which again is how a cow can produce 50 kilos of milk a day. It's a very efficient process to make glucose from VFAs in the liver. Okay, I need to switch to a next topic, and I think I'm going to mess up my system to do that. It seems like I do. Let's see. Will it work this time? No. See, that's what I want.
Because that's going to be
Okay. Seems like every time I do that on this system, I'm.
Maybe we have the screen.
So I wanted to go to.
Try to stop the sharing and
Maybe, yeah.
restart.
What? Stop the
Here?
here.
Uh-huh.
Yeah.
That's a stop sharing.
Yeah.
Yeah,
Yeah, and then you repeat.
restart.
Oh,
Yeah, maybe. Now it's black.
I go down here?
Yeah, here.
I didn't do that one before.
No, why?
No, I was doing this one.
Well, anyway,
Yeah,
we can try both.
Let me see if this will go take it directly. Something happened.
Something happens.
Yes.
Here it is. Here it is.
Is there? Okay.
Yeah.
Okay. How am I doing on time? That's not, yeah, it's getting there. All right. In terms of heifer nutrition, going from here to here, heifer nutrition has some interesting things that I think hopefully you'll be interested for you. The calf starts out as a monogastric. I can skip through this. Yeah, I've showed you that. 4 different time periods when I'm concerned. Ooh. This isn't syncing.
It doesn't go?
Nope, didn't sync. I'll go back to Teams.
Un attimo di pazienza, stiamo cercando di ripristinare bene il collegamento.
Don't know what I did. Yeah, okay. It's,
What happened?
oh, I didn't. Go here?
Well, is that connected to the, how is that connected to the system? To the Wi-Fi?
By Wi-Fi, yeah. I'll see if it catches up here.
Mm-hmm. Yeah.
That's looking okay. Getting really slow.
Is that yours? This?
Yeah.
Oh.
But see, the problem, I'm connecting this by Wi-Fi and it has to go back to Pennsylvania and then come back. So there's going to be a little time delay, but it's a little more than what I like.
Yeah.
Okay, all right. Try to get caught up here. I wasn't sure where all, I think I have it going now. I think we're okay.
Okay, sorry.
From a practical standpoint, as I know some people listening to this are going to want the practical part of it, there's basically 4 time periods when a diet would need to be produced, need to be formulated for a growing heifer, up to 6 months, 6 months to breeding, basically following the growth curve of that animal. At breeding or puberty, I change the diet because she needs less energy, less protein, more energy, and then up to pre-calving and then a close-up diet. In terms of some newly weaned calves, usually for about 8 weeks, this is usually the first time that a calf is in a group environment on most farms. Are you okay? Okay. They need adequate feed bunk space because they're not normally used to that. They need water, they need ventilation. But when do we introduce forage? Now, here's a case where I condensed a whole hour lecture because of a lot of research that's been done, but I've just got 2 slides on that for you. Basically, a lot of different forages can be fed to a young calf, and they do just fine. Basically, if we have a functioning rumen, that animal can use dry forage, they can use ensiled forage, and digest them very well. 50 years ago, it was thought that a young ruminant could only use a dry forage, but that's simply not the case. If the rumen's functioning, the bacteria